Hello everyone, welcome to UpSmart IAS classes. This is your Reddy Prakash and let us now continue with the series of CAPF Assistant Commandant crash course, and with that the subject of chemistry. And for those people who have watched the previous class, I have given you an assignment, a trap. The trap was, why is the valency of lithium 1 not 7? That was a trap. I hope everyone who watched the video have gone through the I've done a basic research and have got to know the reason. If not, for those people who didn't do it, or for the people who are watching the video for the first time, I'll give you a reason. I'll give you why it is 1 not 7. So if we go back, I told you, see, valency of lithium should be 7, but it is 1. And what is the reason for this? What is the valency? Valency means valent, the outermost shell. It is related to the outermost shell. So whenever the atom or the element should be in a stable nature, all its shells should be filled. In a sense, if it is in first shell should be filled. If it is in second shell should be filled. If it is third shell should be filled. Something like that. Okay. Now the lithium is in the second shell. And in the second shell it has one electron. So it has a shortage of -7 electrons. So lithium has a shortage of 7 electrons, or it has an excess of 1 electron. Now how the elements or the atoms behaves is that it will either lose electrons or gain electrons. It will try to get its shells in a stable nature. That is, it will either maintain the second shell with 0 electrons or with complete 8 electrons. Now you say, which is energetically practical and easier for the lithium atom or lithium element to gain the stability? It is either to lose 1 electron, it is either to gain 7 electrons or to lose the 1 electron. Which is easier? So to lose 1 electron is relatively easier than to gain 7 electrons. Where is 7? Where is 1? Losing or gaining 1 electron which is of similar energy, but there we have to gain 7 electron in the first case. In the second case, we can lose the 1 existing electron. So losing 1 electron is easier. That is why the valency of lithium will be 1, not 7. The valency of lithium will be 1, not 7. Okay. Now similarly, I'll take you back to those slides. The other elements also forms the similar reasons. Now you see, the valency of lithium is 1. Now similarly, beryllium has 2 electrons now. To get the stability in the L shell, the second shell, it has to gain 6 electrons or to lose the 2 electrons. Losing 2 electrons is easier, sir. That is the valency of beryllium is 2, not 6. Next, boron. Now it has 3 electrons in the L shell. To get the stability, it has to gain 5 electrons. Getting 5 electrons is easy, or losing 3 electrons is easy. Losing itself is easy, sir. So the valency is 3, not 5. Next is the most important one, the carbon. This is the most important one. The carbon. What carbon does is, now it has 4 electrons in the L shell. To fill the L shell, it has to get 8 electrons. That means it has to gain 4 more electrons. And or to make it 0, it has to lose 4 electrons, which is of equal. Losing 4 electrons is easy. Losing 4 electrons is same as getting 4 electrons. It is of similar energy. So both are energetically difficult for carbon. So what it does is, it will remain as it is. It will remain as it is. So here the valency is 4. This is important. This is called as tetravalent nature of carbon. Tetra means 4. 4-valent nature of carbon. This is important. And in the beginning few elements, only carbon has valency of 4. That is a special characteristic. Next, nitrogen. Nitrogen will be having 5 electrons in the L shell, the second shell. To get the stability, it has to lose 5 electrons or gain 3 electrons. So which is easy. Losing 5 is difficult, then getting 3. So it will get 3. So it is 3. Similarly 2, 1, 0. Then continues again 1, 2. Easy. This is about the concept of valency. So I did it deliberately so that you people can do the research. Had you done the research, it is very good. You have put in an effort. You are in the right stage of the preparation, right path of the preparation. I wholeheartedly believe that you people will ace this examination and become the officers. Okay. So this is the concept of valency, electronic configuration, atomic number, and there is one more column that is called as mass concept. Atomic mass concept, which has to be remembered. I gave you a tabular column of atomic mass of the major elements. The major elements का atomic mass मैंने तो दे दिया था. You have to study that pakka. Okay. Not a difficult concept. Just that I need you people to put in some extra effort. Okay. Now moving on to the next chapter, we'll go to the chapter of carbon, which is very, very, very important for the examinations. Okay. This is very important for the examination, but also a very easy chapter. Slightly you might get a doubts and a revision of multiple times is required. But believe me, this is an easy chapter. You will easily get a question which can be answered easily. Fine with that? Let's move ahead. So, what is the chapter is about? The chapter is about carbon and the compounds it will form and its compound. Carbon and its compound. So, what is carbon? What is carbon? Is carbon a metal? Is carbon a metal? No sir, we have a carbon and it is not metal. So whatever the bodies, whatever the elements which has carbon in it are called as organic compounds. The compounds which has carbon in it are called as organic compounds. The compounds which doesn't have carbon in it are called as inorganic compounds. Usually we confuse organic and inorganic with natural and synthetic compounds. Natural means it has to come naturally, biologically. Synthetic means manufactured by the human. What is organic and inorganic? Those compounds which has carbon as an element within it are called as organic compounds. Those compounds which doesn't have carbon as an element within it are called as inorganic compound. Okay. So carbon is not a metal. Carbon is not a metal. Carbon is present in earth crust and atmosphere as CO2. Most substances around us contain carbon. Those are inorganic compounds. Okay. Easy. Let's move ahead. Next. Test for carbon. How do you test whether a compound has carbon? That means whether a compound is organic or inorganic. How do you test that? There is a laboratory test to do that. Okay, the laboratory test is actually very easy. What we do is we take a pinch of that compound. A pinch of that compound shall be taken. It will be heated under a flame. Then what we do is the heated compound is put into the lime water. If that lime water turns milky in nature, milky in color, then that proves that pinch of compound has carbon in it. That means that pinch of compound is inorganic in nature. If that doesn't change the color, then that proves that it doesn't have carbon. That is inorganic compound. Now see, carbon compounds burn to produce CO2, which turns lime water milky. This is a test to check whether a compound is organic, that is it has a carbon, or inorganic, that is it doesn't have carbon in it. Okay, simple, easy, clarified. This is about the carbon, its nature. How do we test whether a compound has a carbon or not? And if it has a carbon, then it is organic. And if doesn't has a carbon, then it is called as inorganic. Easy, right? Easy. So now, occurrence of carbon. How do you think carbon occurs? See, carbon occurs in two forms. One is the free state. The other one is combined state. Free state means carbon combines with itself. Carbon merges with itself. Carbon. The chain of carbon. Carbon will combine with itself. That is called as free state. Combined state means carbon will combine with some other elements, some other compounds that will form a new compound. That is combined state. We'll see the example of the free state. You have seen the diamonds, right? Diamonds has almost no impurity. It is completely made up of carbon by undergoing thousands of years of pressure and temperature effect on it. So a carbon turns diamond. That is why it is rare, because it needs thousands and millions of years to form a diamond. It is one of the most strongest compound in the world, and it has very less reactivity. Thermally inconductive. It will also be very strong, so it will be used as the cutters, cutting glass and various other compounds. Okay, that is about the diamond. And there is some other thing called as graphite. Similarly, graphene. Usually examiners will try to confuse us between these two. Graphene and graphite. This is some hexagonal compounds. The arrangement of graphene and graphite will be in hexagonal nature. It will be like this, hexagonal. Hexagonal means six-sided. Each side will have a carbon, one carbon on each side. If a layer is one, if it is only one layer and it has 6 compounds, hexagonal in nature, that is called as graphene. If a layer is stacked one above the other, many layers are formed, stacked in nature, then it is called as graphite. This is called as graphene. This is graphite. Okay. Then Buckminster fullerene. This is football like shape. It will be there as football like shape. This will have 60 carbon. See, 60 carbon elements will form this football. This is Buckminster fullerene. We'll discuss all this again. I'm just giving a brief introduction to this compound so that you won't feel this as new words when I discuss this in detail. Easy with this concept, right? The difference between graphene and graphite is very important. Buckminster is ball like shaped. It will have 60 carbons. That is, all these are free state. Only carbon will be present. Now the combined state. Carbon dioxide. See, carbon is there, oxygen is there. Combined. Limestone, marble, chalk. Beyond carbon, there will be many elements in it. Coal, petrol, natural gas, carbohydrates, hydrates will be there, proteins, fats. All these things are not made with only pure carbon. There are other elements combining with carbon. That is why it is called as combined state. Easy, right? Now I remember what is inorganic, sir, what is organic, sir. Now I will properly remember what is free state, what is combined state. Within free state, there are very important examples, like the difference between the graphene and graphite and the Buckminster, that is the C60. Easy, right? And there is a test which is very important for the testing of whether a compound has carbon in it or not. That is also easy. We have understood what a carbon is very neatly now. So let's move ahead. The second thing is properties of carbon. What are the properties of carbon, sir? How do you think the carbon will behave? What are the properties of it? Firstly, if you see, carbon has tetravalency. I told you why tetravalency. Electronic configuration will be 2 and 4 due to 6 atomic number. 6 electrons will be there, 2 here, 4 in the second shell, L shell. It can't lose 4, it can't gain 4. Energetically very difficult. So it will remain 4. The valency will remain 4. Tetravalent. Next is catenation. Catenation means self-linking property of carbon. Carbon can link to itself. Very few elements has the ability to catenate. Catenate means it can link with the same kind of element. That is, C can link with other C. A carbon can link with the other carbon. In the previous class we studied P4S8 means phosphor can link with other 3 phosphor. Sulfur can link with other 7 sulfur. P4. These are other examples, not very important. P4S8. Sulfur can catenate with itself. Phosphorus can catenate with itself. And carbon also has this ability. It can link with itself. That is called as catenation. As a result, a long chain is possible for this. You have seen, no? Usually, carbon compounds will be having a very long chain. Usually, it is carbon only because it can catenate. The other compounds cannot usually catenate. That is, if it has to form a long compound, it has to have equal amount of other elements to link with it. If there is a shortage, it will break. But carbon, how many ever atoms or elements it has, it will still form a chain regardless of which is with it. It doesn't matter for it. And reason is a carbon bond is very strong. If there are other elements, that bond will be very weak, it will break. But carbon and carbon, 4 and 4, right? Valency is 4. It can give 4, take 4, give 4, take 4. If there is other atom coming, if one stability, one will give, one will take, one will give, one will take. That is why carbon chain will be very strong, tetravalency. That is why wherever we see nanotubes, we tell nanotubes are very strong. What are nanotubes made up of? Carbon nanotubes, sir. Because we can form a chain of nanotubes using carbon. Carbon will say stay very strong. Easy? Yes, sir. Easy now. Now I understood, sir. Next is covalent nature. Covalent nature means carbon always forms covalent compounds because gaining or losing 4 electrons is difficult. Covalent nature, because gaining or losing is difficult. So always it will be having 4. It will always have valency 4. It will not lose, it will not gain. It will have like that until another compound comes and makes love with it. That is covalent nature. So it will have 4. It will lose only 4 when it is making love with other things. See, now it does make love with H. Only then it will react. Until then, it will have its valency as it is. Okay. Next, properties of covalent compounds. Any covalent compounds, the properties usually will be low melting and boiling point. Boiling point and melting point will be lower for them. Next, poor conductors of electricity. Poor conductors of electricity, because when you lose, you get a net negative charge. When you gain, you get a net positive charge. That means you are making ions. You are getting a charge or losing a charge. When there is a change in charge, when you have a charge over your head, positive or negative, it can conduct electricity. But what carbon does, it will keep its valency as it is. It will neither lose nor gain. Fine. When it doesn't happen, when that doesn't happen, electricity will be poor. Covalent nature. Okay, tetravalency. Electricity will be poor. That is why diamond, graphite. Graphite means graphite is used in pencil and other lead kind of compounds. Pencil, lubricants and other things. Those will not conduct electricity. Carbon nanotubes will not conduct electricity. Nanotubes are used in aerospace industry. Why they use? One is for the strength. Tetravalency will give a strong strength and it will not conduct electricity. It should be safer. Easier. Now we are understanding why the carbon is important. Carbon is very important, and it is because its unique properties which gives it a unique nature for the improvement of civilization, human civilization. Next, allotropes of carbon. What are allotropes, sir? Allotropes are different forms of carbon having different structure. These are forms of carbon, but they have different structure. One of them I told hexagonal structure, multi-layer stacked structure, football structure. See, the carbon is same, but different forms of carbon, and that will give different structures of carbon. This is the concept. This is called as allotrope, but common element is carbon, that is called as allotropes. Now, diamond will be arranged like this. Now you can see the rings of diamond whenever if you observe arrangement of diamond. It will be in 3D tetrahedral structure. This can be asked. The structure of diamond is 3D tetrahedral structure. Remember the name. Hardest natural substance, transparent and shiny, poor conductor. All this we know. Jewelry, cutting tools and all we know. Next is graphite and graphene. I told you what is graphene. Graphene means single layer of graphite is called as graphene, single layer. If these are stacked one over the other, then it becomes layered hexagonal structure, layered hexagonal graphene structure. It will be soft and slippery. This will be soft and slippery. These are good conductors of electricity. These both are good conductors of electricity. Good conductors of electricity. Used in pencil lead, electrodes, lubricants. Buckminster fuller in C60. Carbon nanotubes or cylindrical tubes. Lonsdaleite, hexagonal diamond. Hexagonal diamond is Lonsdaleite. Easy. We have to remember these names. No shortcuts, sir. We have to remember these names. Okay, my friends. Let's move ahead. Next are organic compounds. I told you what are organic compounds. Organic compound means those compounds which has carbon within it are called as organic compounds. Fine. That we have a clarity, right? That is a very easy concept. Compounds containing carbon are called as organic compounds. What are the major types of organic compounds? We'll discuss each of them in detail. I'm just giving these names in the beginning itself so that again I'm making sure you hear these words again and again. It should hit your head again and again until your head feels like, okay, I have listened this word 1,000 times. I'll read these words for another 1,000 times. Nothing is new for me. Arts wale, commerce wale, this is all for yourself, all for you people. Okay. Now see, hydrocarbons, what we use in fuel. Haloalkanes. Here halo means usually a functional group. It will be chlorine, fluorine, bromine and iodine. Usually this will be the halo groups. I will discuss all of this. I'm just giving a brief introduction. Alcohols will be having OH at end of the long chain. When a chain is there, OH will be at the end of that chain. It is called as alcohol. Next, aldehydes will usually be having CHO. When it has CHO, it is called as aldehydes. Ketones are when it has CO. When a chain has CO at one end, these are called as ketones. When a chain has COOH, then these are called as carboxylic acid. Easy, carboxylic acid. Hydrocarbons, the oil and petroleum. Halo means chlorine, fluorine, bromine, iodine. Alcohols, it has OH at one end. Aldehydes will be having CHO. Ketones will be having CO. Carboxylic acid will be having COOH. Easy. I know it is difficult. I'm telling it easy because I'll make you feel easy. Just I gave a brief introduction. This again we'll study. At that time you'll get perfection. Okay. Now make a pause. Pause it for 30 seconds. Revise again. Haloalkanes, chlorine, fluorine, bromine, iodine. Alcohol, OH. Aldehyde, CHO. Ketone, CO. Carboxylic, COOH. Pause it for another 30 seconds. Revise by yourself. I'll move ahead now. I hope you paused it and studied it. Now we will go to hydrocarbons. What are hydrocarbons? Hydrocarbons means, we know hydrocarbons means usually it is the energy and oil which we consume. But why? Because these compounds contain only carbon and hydrogen. These compounds will be having only carbon and hydrogen. No functional groups like OHO, CHO, COOH, CO. All those things will not be there. Only carbon and hydrogen will be there. Those will form the hydrocarbons. Hydro for hydrogen, carbon for carbons. Those will be having only hydrogen and carbon, so it is called as hydrocarbons. No other functional groups. And within that is a important classification: saturated and unsaturated. For saturated, examples are alkanes, alkenes, alkynes. There are many examples like alkane, alkene, alkynes. Alkanes alkane, alkene, alkynes are examples for hydrocarbons. Alkanes are examples for saturated hydrocarbons. Alkanes are example for saturated hydrocarbons. Alkenes, alkynes are examples for unsaturated hydrocarbon. Unsaturated hydrocarbon. Then what is saturated and unsaturated, sir? Saturated and unsaturated means, I told you, carbon will be having tetravalency, 4 electrons in its outermost shell. It can form 4 bonds at maximum number of bonds it can form is 4 bonds. That too, all the bonds should be one single bond. One single bond will take 1 electron. 4 bonds is the maximum it can form. That is, the saturated nature will have a maximum of 4 bonds and all should be the single bond. That is possible in alkanes, contains single bond. The formula for alkanes, alkenes, alkynes, this I will give you now. I'll teach you nicely. Next is unsaturated. Unsaturated will be having either double or triple bonds. Because it is not saturated, it didn't get to that saturation level. It will form lesser number of bonds, and bonds will be lesser number. It will give its electrons easily, 2 electrons or 3 electrons, 2 or 3. Double or triple bonds will be there. In saturated, only single bonds. It has saturated maximum number of bonds. Easy. Let me take a whiteboard and I'll explain what are alkane, alkene and alkyne. Okay. Alkane, alkene, alkyne. I know these are new for you people. That is why I am explaining it separately so that it will become easy for you people. Alkane, alkene, alkyne. These are forms of hydrocarbons. Alkane is a saturated hydrocarbon. These two are unsaturated hydrocarbons. Unsaturated hydrocarbons meaning it have double or triple bonds. Alkanes will be having only the single bonds. Now I will give you the formula how to remember them. The formula for them are CnH2n plus 2. I told you hydrocarbons means it will be containing only carbon and hydrogen. If this is a formula, it is called as alkane. I'll tell you. Just remember, I'll tell you. Next, in kene, alkenes, if it is having a formula of CnH2n minus 2. Minus 2 from this means CnH2n. Again minus 2. minus 2 means CnH2n. Again we'll do a minus 2. Minus 2 means CnH2n minus 2. Now this is a formula. Sir, why this formula, sir? What will we get from this formula? What will we get from this formula? If the number of hydrogens and carbons are similar to these formulas or satisfying these formulas, then those can be classified as alkane, alkene, alkyne. I'll give you the examples now. See, take everybody watching this class should take a screenshot or write along with me in a plain paper. Number of n, the value of n. If the value of n is 1, then what happens? C into 1, C1, H2n, this is 1 right now, 2 into 1 is 2 plus 2, 4, C1H4, that is nothing but CH4, right? C1H4 is nothing but CH4. Now substitute 1 here. What will happen? C1 means C. H2n means 2 into 1, 2, CH2. Substitute it here. C1 H2n minus 2. H2n minus 2. Is it possible? 2n minus 2 will become 0. 0. 4 to 0. Only C will be there. If n is only 1, then it is called as meth. I'll tell you why meth. Methane or meth. Meth. Now what we are telling this as meth. It is called as ane, alkane. Meth is the name. It ends with ane. Ene. Ine. Right. Now this CH4 is called as methane. This CH2 is called as methane. This as a compound doesn't exist. Fine, this as a compound doesn't exist because no hydrogen. When there is no hydrogen, it doesn't satisfy hydrocarbons. Now next, if N is 2, then it is called as eth. 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 Then substitute 2 into this formula. C will become 2. 2 into 2, 4. 4 plus 2, 6. CH4, and this will be named as, this can be named as ethno and ane, ethane. Eth is the keyword and A is the ending word, ethane. Now next is we are substituting 2 here, means C2, 2 into 2, 4, C2H4. C2H4, the word keyword is eth here and ends with ene. That means this is ethene. Now we substitute 2 here, means C2H2n minus 2. 2 into 2 means 4. 4 minus 2 is 2. C2H2. Now we get a compound here. We have eth as a keyword. The ending word is ine. This is called as ethine. Now we understood. Now we would have heard these words, right? Methane, methane, ethane, ethene, ethine. Confusing? Similarly, when it is 3, it is called as probe. The keyword is probe. When the number is 4, the keyword is called as butane. Don't call it as butane, butane. Now you can get a hold of this, right? Understood why it is named like this, why it is called as alkane, alkene, alkyne, and again to clarify why only single bond. Now you see why only single bond. Now we have CH4. I told you maximum number of bonds it can create is 4 because single bond. C will be like this, H, maximum number of bonds are 4, all are single bonds. If it is C2H6, this will be like C first, it will form with itself. Next is 1, 2, 3, 4, 5, 6. C2H6, all are single bond, right? That is why alkanes form single bonds. These are saturated in nature. Understood with this concept? Easy. Revise it 2-3 times. Understand why it is called like that, why it is named like that, why single bond, why there need double and triple bonds there. You will get a hold of chemistry. Easy, sir. Next is, these are, I explained all these things now. Why methane, ethane, propane, butane. When it is 5, it is called pent. Keyword is pent. Pentene, pentine. Easy. Unsaturated. Similarly, we'll get you alkenes. The word ethene. I told you why ethene, why protein, how they are formed. See, here we'll get the double bond. We need a double bond to satisfy the formula here. Okay, understood, right? Easy. Next are alkynes and functional groups. I told you a few functional groups. I told you what are alkynes, ethane, propane, butane. I explained all this to you. And see here we'll be getting triple bond. Got a hold of concept? Easy, sir. Functional groups. Functional groups are group of atoms responsible for characteristic properties. Now you see alcohol has a certain property. By that property is due to the functional group of C and H compound having at its end. The functional group of alcohol is OH. I told you alcohol is OH. Halo means X. It is represented by X because it will be having various other compounds like chlorine, fluorine, bromine and iodine. It's not one functional group, it is many functional groups for halo. Chlorine, fluorine, bromine, iodine. For alcohol, OH. Ketone, CO. If you add one more H, it becomes aldehyde. If you add one more O, it becomes carboxylic. Ether is ROR, means hydrocarbon connected with R. Hydrocarbon. Ester is COOR. COO connected with the hydrocarbon. R means hydrocarbon. These functional group names, you have to be pakka. You have to get a hold of functional group names. You have to remember that. Next, homologous and nomenclature. Homologous series means, homologous compounds means a group of compounds having same functional group means OH or CO or COH or CHO. Functional group will be same, then it is called as homologous compounds. Similar chemical properties. If the functional group is same, chemical properties will more or less be same. Similar chemical properties. Successive members differ by 2. Now this is a main condition. Each successive member should differ by CH2. Now we have an example here. See, CH4. Add another CH2 to this. That will become, C will become C2, H4 will become H6. Add another CH2 to this. C2 will become C3, H6 will become H4. Add another CH2 to this, CH2. C3 will become C4, H8 will become H10. Keep on adding CH2. Each successive member should differ by CH2. Then those are called as homologous series. Homologous series. Understood the meaning of homologous series? Yes. Now the nomenclature. Nomenclature. I told you, alkane will end with ane, alkene will end with ene, alkyne will end with wine, alcohol will end with OL, and it will have a functional group of OH. Aldehyde will end with all. Aldehyde will end with all, AL, and aldehyde will have a functional group of CHO. Ketone will end with one, and it will have a functional group of CHO. Here C double bond O in the ketone. Carboxylic acid will end with oic acid. The compounds will end its nomenclature with oic acid. These will have functional group of COOH. Sir. Example, see, ethane, ethyne, ethanol. Carboxylic acid example is ethanoic acid. It will end with oic acid. Oic acid. Easy. Just the names. Next are chemical properties, very important. Chemical properties, very important. Chemical properties of carbon. Combustion. When you burn a carbon, what happens? It will release carbon will become carbon dioxide. It will be tell you. When you burn hydrocarbons, when you burn petrol, what happens? When you burn petrol, it will release more carbon dioxide, sir. We keep telling Paris Agreement, environmental changes, environmental mitigation, environmental adaptation. We keep telling this thing, and we tell we shouldn't consume fuel. We should limit the fuel. Why? By burning fuel. While burning hydrocarbons, what happens is oxygen will mix with the hydrocarbons, and it will combine to form carbon dioxide. Along with it, water will be released, heat, light. These things will be released. And one more thing, when you burn a hydrocarbon, example, gas burner at your home, a gas cylinder will be right, and top of that will have a gas burner. Have you ever observed, if you keep a high flame, the flame you will observe a bluish color. When the strength of the flame is more, you will observe a bluish color. When the strength of the flame is low, you keep the flame at sim control, then it will be having yellow color, yellow smoky flame. Blue flame means very strong. Blue flame means very strong. You would have seen these people with welding, right? Welding people. They'll be having that gas cylinder ka gun. While they burn it, the flame will come out in blue color, not the yellow color, because that is very strong in nature, very strong flame. But at our homes, usually it is yellow to red. That means some sort of lower strength. Okay. Next is substitution reaction. Substitution reaction means hydrogen atom in the hydrocarbon is replaced with other atom. Now see, this is a hydrocarbon, CH4, only carbon and hydrogen is present. This is an hydrogen atom. If this is replaced by any other atom, then it is called as substitution, substituting the hydrogen with any other atom. Now you can substitute with Cl, then it will become CH. We need not remember this. Just remember, if they give this equation, or just remember substitution means hydrogen is replaced, substituted. See, hydrogen is going to become HCl and other things remain to become CH3Cl. This happens in the presence of sunlight. Okay. Next is addition reaction. What will you add, sir? When unsaturated hydrocarbons will be there, right? Unsaturated hydrocarbons means double and triple bonds will be there. To that, if we add hydrogen, then it will lead to saturated hydrocarbons. You will get single bonded hydrocarbons, saturated hydrocarbons. This process is called as addition reaction. What you will add? Hydrogen is added. In substitution, what you will substitute? Hydrogen is substituted. Here, to speed up this process, there will be catalyst. To speed up this process, there will be catalyst called as nickel and palladium. You have seen this vanaspati, right? Dalda, vanaspati. They add it to ghee rice and other rice as a substitute for ghee, because it is of lower price. How do you get this vanaspati? It is very bad in nature. How do you get this vanaspati? We'll be having this vegetable oil, right? Vegetable oil. We'll put it in treatment with hydrogen. We'll compress it with hydrogen in the presence of catalysts like nickel and palladium. Then it will go on to become vanaspati ghee. Named it as vanaspati ghee, but it's not an actual ghee. It is basically the oil which we added to our food. It is very bad in nature. Next, few other reactions are oxidation reaction. Oxidation reaction. Oxidation means oxygen. You are adding the oxygen. If there is alcohol, OH. If there is OH in oxidation, if there is OH, what happens is, if you are adding another O, then it will form water. Then it will leave. OH will go. It will form a acid. Example, you need not remember equations. Just remember oxidation means alcohol will become acid. That is more than enough. Next, esterification. Esterification means, now if you add oxygen to alcohol, you will get acid. If you add acid only to alcohol, then you will get ester and water. This is esterification. Esterification means you are getting ester. How do you get ester? We'll add acid to alcohol. That is called as esterification. Fine, easy. Next, esters have pleasant smell and are used in perfumes. Perfumes are usually made up of ester. With the process of esterification, we'll be telling now, perfumes will have alcoholic base. Because to those alcohol, what we do is we put some acids, specific acids, and some flavors. Okay, by doing that, what we will get is the perfumes. That is why perfumes will have the alcoholic base. When we spray, it will get dried quickly because alcohol will dry quickly, and that acid will give you a certain flavor. To that, we will have other additive flavors as per our desire. Okay, this is esterification. Next, isomerism. Isomerism is a chemical property. What does this mean, sir? Isomerism means compounds have same molecular formula but different structure. See now, butane. Butane means you will have 4C and 10H. 4C, 10H. 4C plus 10H is a butane. But the same butane can be arranged differently. How you will arrange? It can be arranged in this manner also. You need not remember the structure and all. Just remember the other form is called as isobutane. Chemical formula is same, C4H10, but the way it is arranged is different to form a isobutane. Iso means similar, exact similar. So chemical formula is same, structure is different. Those cases are called as isomerism. Easy. Next, ethanol and types of alcohols. Ethanol means, I told you, eth means two carbon compounds. OL means OH, will have OH at the end. C2H5OH. This is ethanol. It is also called as ethyl alcohol or grain alcohol. Uses, perfumes, medicine, fuel, everything will be there. But types of ethyl alcohol: rectified spirit, alcohol, absolute alcohol. Absolute alcohol means almost pure alcohol. 99% will be alcohol. Rectified means 95%. You can read this. Power alcohol, gas oil, you should remember this. Easy only. Okay. Next is methanol and methane. Methanol and methane. I told methanol means, meth means one carbon. CH3OH. CH3OH. This is methanol. It is also called as wood spirit. Wood spirit means methanol. The other ones are ethanol. Properties, just read this. It is poisonous. It may cause blindness. If we take more, we can die. This is called as methanol. That is why the alcohol which we consume is ethanol, not methanol. Methanol is very dangerous. We consume ethanol. Next is methane, CH4. It is also called as marsh gas, gobar gas, biogas. The plants of gobar gas and biogas give out methane, so that it is also called as gobar gas and biogas and marsh gas. Because Why marsh gas? Marshes will be now like marshy lands. These will release CH4. These will release methane. So it is also called as marsh gas. Okay, easy. Next is ethanoic acid and reactions of ethanoic acid. What are ethanoic acid now? Ethanoic acid, I told. Oic acid means carboxylic acid. Oic means carboxylic acid. Now what is carboxylic acid, sir? What is the functional group of carboxylic acid? Functional group is COOH. We discussed this, right? COOH. Now you see, we have COOH here. So it is ethanoic, and eth means 2. C2. C1, C2. C1, C2. Easy. It is also called as, you can remember this name. The vinegar which we use is ethanoic acid. The acetic acid, glacial acetic acid, vinegar. These are ethanoic acids. 5 to 8% of ethanoic acid is used in these compounds. Okay. Uses, you can study the uses and other things. Next is reactions of ethanoic acid. If you react this ethanoic acid, if you react CH3 COOH, what will become? If you react this with a base, base means NaOH. NaOH. Base is NaOH. If you react with acid, if you are reacting a acid, this is a acid. This is a base. I told you, acid and base mix means the process is called as neutralization. When you neutralize acid and base, what you will get? You will get a salt and water. Salt and water. This is a salt, this is a water. Water will be released. When it is reacted with carbonates and bicarbonates, carbonates and bicarbonates, carbonates and bicarbonates are also base in nature, but it also has C in it. So what extra will be formed is acid plus base will give you salt and water for sure. If you have carbon, you will get CO2 also. Easy now? Sir, always I thought equations are difficult. Now if you follow the flow of classes, if you study each class properly, is it difficult now? Seriously, is it difficult now? No, right? Next is saponification. Saponification means you are getting soap. You are getting soap. The way you get soap is called as saponification. Saponification. You know ester, right? Ester. How? Ester. How in the process of perfume we'll get that ester. If that ester is mixed with NaOH, we'll get soap and alcohol. That is process of esterification. This process is used in soap manufacturing. Well, soap manufacturing will use this process, saponification, to get soaps. Next are important compounds and uses, which I will not explain. You should study. These are the compounds and where it's used. Easy only, you can study by yourself. Okay. Next are soaps and the properties. I told you saponification. Saponification means if you mix ester with alcohol, you will get soap. Okay. That soap. This is the process of manufacturing soap. Now how? What are soaps? Soaps are different from detergents. Remember this. This is the main confusion. We might think like soap and detergents are made up of similar compounds, similar chemical composition. No. Soaps are different. Detergents are different. Detergent which we use for our clothes is different. Soaps which we use for our skin and clothes are different. Soaps are completely different. Soaps are made up of sodium and potassium. It should have pK, P or K, and it should be long chain acids. These are not base. These are acids, and the long chain should be fatty. Some kind of fat like structures will be there. Depth is not required, just understand the difference, basic difference, and the nature is enough for the examinations. Now, sodium and potassium long chain fatty acids, these are soaps. Then what are detergents? Detergents are sodium salts of sulfonic acid. Sodium salts, and this is sulfonic acid. Sodium salts, sulfonic acid, not the fatty chains. Okay, these are detergents. Now we can often wonder how a soap acts. We'll keep seeing those ads, right? Ariel detergent powder, Ariel soaps or various other soaps. It will remove dirt. It will keep you healthy. Dettol soaps. It will remove dirt from your body. It will remove everything from your body. It will make you clean. Hygiene. Doctor certified. All this is okay. What is the process? How it will make us clean? How the detergent will clean the clothes? This process is important. Especially soap process is important more than the detergent process. Soap process. What happens in the soap is when a soap molecule is used, micelles means tiny compounds is separated from soap. The tiny compounds are called as micelles. Those tiny compounds are micelles. Soap molecules form the micelles, and the hydrocarbon end. One end will be, it will be like two ends. One end will be hydrocarbon end. The other end will be ionic, means charged compound end. Charged ion. Two ends. Chain will be there. Chain of sodium and potassium, long chain fatty acid. One end will have hydrocarbon. The other end will have charged ions. What the hydrocarbon does is, it will remove the grease. If there is any grease, hydrocarbon grease, it will remove the grease. What the ionic end does is, it will dissolve in water. It will react with water and it will dissolve in water easily. Okay. Next, micelles. And what the micelles does is, it will trap the dirt and wash it away. And soap solution appears cloudy because micelles scatter light. Soap solution, usually it will seem cloudy, not clear, because it will keep on scattering light. Okay. The cloudy nature is not due to dirt, but due to scattering of light. The dirt and micelles together will scatter the light, and that will reduce the transparency. Okay. Next, detergents, I told you, sodium salts of sulfonic acid. Advantages: effective in hard water, do not form scum. We'll be telling soaps to perform properly, we should have soft water, not hard water. But detergent can perform in hard water also properly. And these do not form the scum. Soaps will form the scum. Next, uses: washing powder, shampoos. Detergents are also used in shampoos. Next, this is easy, which we already know. Environmental pollution of hydrocarbons and carbons are always there. Majorly it will release sulfur and nitrogen. Sulfur is cooling. It will cool the temperature, sulfur. But it is not good for health. It will cool. It is global cooling compound, not heating compound. Carbon is heating. Sulfur is cooling. And nitrogen also it will release, and it will cause acid rain. And this is very easy. Tetravalency means 4. Catenation means self-linking property of carbon. Allotropes means different forms. Hydrocarbon you know. Functional groups you know. Homologous carbons we discussed. Esterification, acid plus alcohol will give the ester used in perfumes. Saponification is manufacturing process of soap. Micelles, isomerism. This is all about carbon and its compound. Very important for the examination. Also easy for the examination. Get a hold of it. All the best. Have a good studying future. Become officers. This is all I hope for always. Okay. Thank you. For any course details to join our personal mentorship, contact the number displaying here. Thank you. Thank you so much. This is your Reddy Prakash. Bye bye.